distances between 2 points. And of course, if they were horizontal, like in the same horizontal line or same vertical line, we could easily count the distances. But if they are diagonal, we can't, because this is not the same as that. So we can't really count those, but we can use the Pythagorean theorem to find our distance. This is just the same as the distance formula. If you've ever learned that, it is just simply just putting it where it looks a little different, but it is essentially the same thing. So this point is 1, 1, and then this one is 1, 2, 3, 3, 3. So if I were to make a right triangle with this, and I want to find what this is, I would have to find what this distance is. And it's easy right now to count, but sometimes we can't count those. So we would simply do, take your larger x and subtract your smaller y. So 3 minus 1, and you would get 2 here. And yes, we can count that and see that that's 2 boxes or units over. And we would do the same thing for a vertical. So 3 minus 1, and you get 2 here. And now we're just going to set up our Pythagorean theorem. This will be c squared. We don't even have to solve it all the way. We just need no, I'm sorry. We do need to solve that. I'm sorry. Wrong thing. So, yes, we will have to solve it for C. So, it doesn't matter. In this case, they're the same, but it doesn't matter these legs, these dotted lines, which one's A, which one's B, as long as they are A and B. And the X here, the hypotenuse of our imaginary right triangle, would be our C. So we'd have 2 squared plus 2 squared equals C squared. So we have 4 plus 4 equals 8. That's still C squared. So now we have to solve for C, not C squared. So to get rid of the square, you would just take the square root in this. And you can leave it as square root 8, or you can simplify it out, or you can put it in the calculator if your options were a decimal. I prefer this, but it's whatever your teacher prefers, or whatever if it was a multiple choice test, whatever your options are. So our distance here would be 2 square root of 2 from this point to this point. Now you will also see this sometimes with a triangle. A circle. And let's see if I can get one going here. It's going to be ugly. And say that I have, let's just say, here's my center. And I'm going to I'll go 3 units out. My radius is going to be 3. And we'll write all this down. I'm just trying to get a circle that looks decent. All right, so say my radius is 3 in this circle, and I want to know if 1, 2, 5 were on this circle. Now, this circle is not perfect. It was not drawn with a compass. So, is this on the circle? Well, it could be. I don't know. So most of the time you'll see this without the graph behind it. So let's just say, well, we don't have the graph, so we can't count it, or it's a larger circle and we can't count. So we are going to make a right triangle here, and we want to see if this is 3. So we are going to put 3 in here. This point, if we have this point, we have 1, 2, We know that this point here is 2, 5 because that's the point that was given to us. So we're going to go, for our horizontal, we go 2 minus 1, which is the 2 is from here, not from the point that this is. So 2 minus 1 is 1. And then we're going to go 5 minus 2, and that gives you 3. So we are going to see if this equation is a true equation. So 1 squared is 1, 3 squared is 9, that gives us 10, and 3 squared here is 9. So that is not true, so this is not on the circle. Like I said, most of the time you'll see this without the graph behind it. This one was an easy one to see. Hey, that's not on the circle. But sometimes you can't tell if it's 3 units away or however many units.